like how much I can impart to you. Here is what I hope to impart to you through the course of this talk. In short, how to deploy PHP applications using Docker, but more specifically, Docker Compose, because I guess Docker is kind of quite a broad umbrella, if you will. Now, more specifically, I hope to impart to you how to build a Docker-based local development environment, along with how to test that and to deploy to it, how to build a deployment setup from the development version, where you can then use that to deploy to production or any other environment, staging, testing, whatever. How to build and tag self-contained Docker images, which will be required for a remote environment. How to push those images to a remote Docker image registry. That way, no matter where your deployment's made from, the images that make up the application will be accessible. Then, how to test the production deployment before making it, reducing the likelihood of something going wrong during your deployment. And finally, how to deploy your PHP application to your remote environment using Docker Compose. Now, one other little thing, which I always feel is important too, mainly because I want to make sure that I set the, what would you say, my expectations correctly, so that you can then double check with me at the end if I met those expectations and I didn't, what would you say, that I just want to make sure that, you know, what I deliver is what, you know, what I've said I'm going to deliver. So I feel I'll cover both sides of this coin here and say that, as well as saying what the talk is, I think it's important, if just briefly, to cover what the talk isn't. Now, what it isn't is not a deep dive or advanced Docker talk or course, as the slide says. Rather, it covers the foundations of what's required to deploy PHP applications, both locally and to remote environments with Docker Compose. I hope that I set the expectations for what I'm about to cover fully. Now, this whole process, the whole crux effectively of my talk, is made possible by Docker's architecture. And quoting the official docs, as you can see here on the slide, Docker uses a client-server architecture. The Docker client talks to the Docker Daemon, which does the heavy lifting of building, running, and distributing your Docker containers. The Docker client and the Docker Daemon can run on the same system, and by default they do, or you can configure it such that the Docker client connects to a remote daemon. The Docker client and daemon communicate using a REST API over Unix sockets or a network interface. So given that, you can use a Docker Compose, fudging my words there, to deploy to your local machine or a remote host, or in a workflow tool such as GitLab CI, GitHub Actions, and so forth, to deploy to any environment that you choose. Now, the process that I'm covering in this talk tonight is basically a condensed version of what I used to do, and a much more simplified version of what I thought you had to do quite some years ago. In short, it's that you don't need any other commands, such as Docker Swarm or Kubernetes, to make a deployment. You can keep it all or do it all with just a few set of core Docker commands. Now, to be fair, there are more advanced ways to deploy applications with Docker than I'll show this evening, but depending on your requirements, this approach may be all that you need. The main thing to keep in mind is which Docker daemon the client is connecting to. So, why deploy with Docker, especially as there are so many other deployment options available? Well, I'll speak for myself and say that in my experience, after learning enough about Docker and getting a few more gray hairs, and if you could see behind me here, if I had like behind me cam, a few more white hairs, I've found Docker to be, generally speaking, a simpler, more homogeneous way of deploying than I'd been used to in the past, using tools such as Rocketeer, Capistrano, and rsync over SSH. I found also that by using some standardized files and a small set of Docker commands, that I can deploy an application almost as easily to production as I can on my local development machine. What's more, so can any other developer on a project, because you can share that configuration around as part of the project. I admit that what I'm going to step through this evening is independent of any continuous deployment tools, such as Circle CI or GitHub Actions, and that when using them, it's not quite as straightforward, not quite as simple, but conceptually, what I cover tonight can be implemented in those tools. Before we dive in just that much further, there are a few things that you'll need to follow this process and to get the most out of the talk. Firstly, a broad familiarity or understanding with Docker, such as terms like image, container, and service. If you're using Linux, then you need Docker Engine. If you're on Mac OS or Windows, Docker Engine as well, or Docker Desktop, which probably would just make things that bit easier. I'm not going to get into like the love, hate between Mac OS and Docker Desktop. I'll just say for the most part, it'll just get you up and running quite quickly. Next is Docker Compose. Now, regardless of the operating system that you're using, I do, generally speaking, encourage Docker Compose version 2. I appreciate that, and I haven't checked it for a little bit, that Compose version 2 isn't necessarily, I think, feature complete with version 1. But one thing that I did find late last year when I was setting up a GitHub workflow for a project is that while you can use version 1, I found version 2 to deploy significantly faster, as it didn't open as many SSH connections. What's more, because of that, you're less likely to hit firewall rate limits, which further exacerbate the deployment time. In the worst case scenario, I think what ultimately became a 26-second deployment time with version 2 took about 23 minutes with version 1. Anyway, getting back to the list of things. You're also going to need access to a Docker image registry, such as Docker Hub or DigitalOcean's container registry. And finally, naturally enough, a deployment server running Docker. So let's talk about the demo application that I'll use in this talk, because every kind of talk, every sort of demo or tutorial needs something to base itself around, so that the information that you're taking in makes just that much more sense. So here's mine. It's not exactly the flashiest thing, but I'm not a designer either. And while it's not that important really to the crux of the talk, it's a small application that I wrote which uses the Mezio framework. It lists the main cast of Hawaii 5.0 from the 2010 to 2020 reboot, including the actors' profile pictures, names, and character names. It's not that sophisticated an application, rather quite a simplistic one that reads the records from a MariaDB database and just renders them to the page, as you can see here on the slide. It doesn't make use of any logging, queuing, or caching services. Now, I deliberately decided to keep the requirements relatively modest here, so that they didn't distract from the talk's primary purpose of learning about deploying the application rather than developing it. That said, if you feel through the course of the talk that it could do with some more complexity in terms of its structure, please just let me know at the end, or feel free to email or tweet me at any given time. Now, as cheesy as this may sound, I got into Hawaii 5.0, hence the reason why I've developed the talk app around it, because my wife and I got married there, and it's a really, really wonderful place. If you haven't been and you get the opportunity to go, it is amazing, every bit as beautiful as this photo makes out. Now, digging deeper, the app will need 3 Docker services for it to function. Those being a PHP runtime, a web server to serve the static content, and a database server to provide the dynamic information. This composition follows the Docker ethos of one process or service per container. Now, here we are. We've done a whole stack of housekeeping. We're kind of effectively getting into the core of what you need to do at this point. So let's create the directory structure and then the development configuration. Now, as you can see here on the right-hand side of the slide, I usually use a somewhat simplistic structure in the root directory of a given PHP project in a directory named Docker. I don't have a special reason for this other than noticing that it was what other people seemed to use when I was learning, and that it generally speaking worked for me as well. Inside the top level Docker directory, you can see that there are directories for development and for production, which are then subdivided for the services within the application's configuration. Then, within each of the service directories is a Docker file containing the instructions, where relevant, for building the underlying image that provides that given service, if they're required. And we'll see those a little bit later in the talk. Now, alongside the Docker file are any supporting files for that image, such as default.conf for the Nginx image, which overrides the default Nginx configuration file, and dump SQL for the database service. Now, in addition to these files, I have a base Docker compose file, which contains the configuration for the application that's applicable to every environment. And along with that base file, I have a Docker compose file for each specific environment. As you'll see a little bit later on, the environment-specific files contain additional settings or override existing ones. This is an approach that I've started to take primarily over the last couple of weeks at least, because I've started to find that this approach is making everything easier to create, to understand, and to maintain. As a little bit of, or would you say, complete transparency, when I started this talk off, I had, as you can see in the directory structure, the same approach, but it was pretty much duplicated, or in large part between development and production. But progressively, as I've sort of come to get used to having a base compose file and then extending that for each environment, I found it makes things just simpler. There's less duplication, less work, less effort. Now, let's start working through the Docker files for each of the relevant development services. We'll start off with the Nginx Dockerfile, which you can see here. Now, it doesn't do a whole lot because in development, there's not a great need to do anything. But what it does do is it starts by using the Alpine Linux version of the official Docker Hub image. You can base an image on whatever other base image that you like, whether that's an official Docker Hub image or one from somewhere else, perhaps even one that you or a coworker have made, so long as you trust that image. I find it personally helpful to use Alpine Linux base images. This is because they're often much smaller than base images using other distributions such as Ubuntu or Debian, often around about 5 meg in size, or at least starting off at 5 meg in size, or around that point. Consequently, this can reduce your image hosting and your transfer costs and reduce the time to make a deployment. And it's more or less one of the Docker best practices for writing Docker files. Now, getting back to the Docker file, the copy instruction copies the Nginx configuration in docker/development/nginx/default.conf on the local development machine to /etc/nginx/conf.d inside the container, as I want to override the default Nginx configuration because it doesn't quite do what I want to do. The Nginx configuration file, which you can see here, isn't all that special. However, it extends the default configuration to send all requests to /public/index.php, which are then passed off to the PHP service on the services on port 9000 on that service. This here is just meant to be like just the key things that I needed to do. You could obviously put any other configuration in there that you needed to. I just didn't put more in there because I didn't want to distract from what I guess I really needed to talk about here. Next, let's look at the PHP Services Docker file. Now, this one is effectively equally as basic as the Nginx Dockerfile. There are a lot more things that you could do, obviously. I just didn't want to overdo it and make the slides really hard to read. So I've deliberately erred on the side of less is more and not sort of trying to avoid something or have something too dumbed down, if you will. But it bases itself on the Alpine Linux official Docker Hub PHP image, specifically using PHP FPM and PHP 8.1. After that, it runs Docker PHP ext install, which, if you're not familiar, is a custom script that comes with the official Docker Hub PHP image, which is one reason that I usually like to use it, which makes it pretty trivial to install a number of PHP extensions. It doesn't do everything though, such as installing the dependencies which a particular extension depends on. So if the underlying image is missing those dependencies, such as for the zip extension or the internationalization extension, then the script will fail. But in this case, however, the base image has all of the required dependencies. Now, as the configuration is for development, it also uses Peckle to install xdebug and the Docker PHP ext enable script that also comes with the image to enable it. Now, if you needed to set PHP ini settings or do other things, then you could do that here as well. Maybe also such as configuring error logging. So let's look at the last Docker file, which is the databases Docker file. Now, the reason for this one is to simplify creating the database schema and loading data into the database inside the image. That way, when the application is deployed, the database is ready to go. Now, there are a host of ways that you can do this, and I guess in all likelihood, you'd probably use a professional database hosting service, such as DigitalOcean's database service, ScaleGrid, Heroku, or something else, perhaps in tandem with a migration tool, such as Doctrine Migrations. But for simplicity's sake, we're just going to do it this way tonight. Now, the copy instruction copies a SQL file, which we'll cover in the next two slides, into Docker entry point initdb.d inside the image. Now, this is because MariaDB and MySQL, those images or the official images, when they're created, if they find a .sh, SQL, SQL.gz, or SQL.xz file in that directory, then they'll run it. Now, here is at least a part of the SQL file. As you can see, it's pretty small, something I created with MySQL dump, which contains some of the instructions for creating the database schema. It's not meant to be a Flash database. It also inserts a set of records into the table once the table has been created. And you can see here we have all of the actors from the show, or at least the main actors, a fake email, and a primary key ID for them. Did I mention I am a huge Hawaii Five-0 fan? I mean, after all, the lead actor was Australian. Anyway, but seriously, with the Docker files and supporting files ready, let's now work through the Docker Compose files. Starting off with the base file, which is dockercompose.yml, or the default file that Docker Compose will look for. The configuration starts by setting up a persistable file system volume, which is used by the database container. Now, this is important because while file systems in Docker containers are writable, they don't persist changes across container restarts. Now, this is because when a container is started, it uses the specified image at the time that it was created, which naturally doesn't have any new files nor changes to any existing ones. Now, this has benefits, but it's not a great thing when working with databases or other storage mechanisms. Hence, while we're creating a persistable volume, where any new files and changes to existing files will be kept across container restarts. We next define an element called services. Now, this element, which I've split up over a number of slides as it's just far too long, for one, lists the definitions of the 3 services or containers which make up the application. And you can see the first one here. It starts off with the Nginx container. Given that it's named Nginx, the container will have a matching hostname of Nginx as well. Note that it doesn't contain an image option to specify a base image to use or a build option to tell it where to get its instructions from. These will be specified in the environment-specific Docker Compose file. Next, it sets the restart directive to unless stopped. By doing this, Docker will restart the container if it should crash or stop for some reason, other than when running Docker Compose down and intentionally stopping it. Now, the restart directive supports 4 values, which you can see here. Those being no, always, on failure, and unless stopped, which we've covered. Just to go through it, if this is your first time seeing it, no is the default, and the container won't be restarted for any reason. Always is that the container will always be restarted. If it's manually stopped, it's restarted only when the Docker daemon restarts or the container itself is manually restarted. And on failure is Docker restarts the container if the exit code indicates an on failure error. Now next, the depends on option creates a dependency between this service and the PHP service, which we'll define shortly. In short, it means that the Nginx service won't start until the PHP service is started, because the Nginx service needs to work with the PHP service, so it needs to be up and going first. The last configuration for this container is to add a health check. Now, these determine if a container is considered healthy or need to be restarted. Health checks gladly can be whatever you want them to be. There's no hard and fast rule for what they are. In the case of this particular application, by default, Mezio applications, or those that are created from the Mezio skeleton project, come with a ping endpoint, which returns a JSON response containing the current timestamp. So I thought that'd be a arguably effective, simplistic way of testing whether the application is working. So looking at the 4 options to the health check, the health check makes up to 3, in this case, curl requests to that endpoint every 60 seconds, allowing for a 3-second timeout. If 3 attempts to the endpoint fail, the container is considered unhealthy and is restarted. That's also something to be aware of if you do, if you're using that in a workflow tool or a CI tool like GitHub Actions, because that will drag out a little bit the time before the a redeployment is finished, which I discovered kind of the hard way, and I'm still getting more familiar with. Now, the configuration for the PHP container is similar-ish, if that's a word, to that of the Nginx container. You can see that, like the Nginx container, it starts by naming the service PHP, and in so doing, giving that container the host name of PHP as well. As before, the container or service is then set to restart if it should stop, unless we stop it. And the expose option exposes port 9000 inside the container or from the container, but without publishing it to the host machine. So in doing that, it makes that port accessible from the Nginx and other services within the configuration. Now for the database service. As with the other containers, we've given it a name and set it to always restart unless stopped. This time though, we're using the build directive to tell it to use the Dockerfile located in docker/development/database, which we stepped through before, to use for its build instructions. And finally, it maps port 3306 in the container to port 3306 on the host machine, so that GUI tools such as the MariaDB or MySQL command line client, or a full-blown GUI tool such as DataGrip or the database tool inside PHP Storm, can be used to administer and interact with the database. Right, let's create a Docker Compose file for the development environment, which will then expand on the base file that we've just stepped through. As I mentioned earlier, it'll contain additional directives relevant to this environment or overrides for existing settings in that base file. So starting off again with the Nginx image, it adds on that it uses the image option to tell it the base image to use, specifically the latest version of the official Docker Hub Nginx image. It uses the ports option to map port 80 in this service to port 8080 on the host machine, which is just my standard default, and I've noticed that it just seems to be that, or port 8000 is the de facto development port to use. And then the volumes option, excuse me, the custom Nginx configuration file, which we stepped through earlier, is copied into the image in place of the default version. After that, the current directory on the host machine is mounted inside the container at /var/all the w's/html. So this lets us develop locally on our host machine, yet have the code be accessible at the same time to the Nginx container, which in turn has the effect of sharing the local directory with the container, I guess analogous to Vagrant's shared folders, which makes local development kind of efficient. When you make a change in your development environment, whether in a text editor like Vim or Pico, or an IDE such as PHP Storm, the changes are available in the container as well. There's no need to manually copy or sync files between the development environment and the container. I believe there is like a tiny delay though, like an ever so slight lag, but I don't remember if it's more than like half a second. I think I haven't actually tested it, but I've noticed at times there can be just this little lag. Now, let's step through the PHP service. The build directive, as we've seen, tells it to use the Dockerfile located in Docker Development PHP, which we stepped through before for its build instructions. And as with the Nginx service, it maps the local directory on the development machine to /var/www/html in the container. Finally, I'm sorry, there is a bit to cover, but hopefully it's progressing in a logical manner. Let's look at the changes for the database service. Now it sets the environment option, uses the environment option where we can pass environment variables to the container. In this case, we're setting 3. These are for the database user's username and password and the database name. You can find a list of the predefined variables for this particular image in the image's official documentation, or if you were using another one of the official database images like MySQL, PostgreSQL, and so forth, you'll find that, I believe, on the main page of the documentation. Then, using the volumes directive, we're making any changes in /var/live/MySQL, where MariaDB stores its data files permanent, as they'll be written to the local data directory in the project's root. And now that we've finished the Docker Compose configuration, it's time to deploy the application locally using Docker Compose. To do that, as you can see here in this example command, we call Docker Compose up. Now, to the command, we pass the file option twice, once for each of the Docker Compose files that we're using. So the base file and then the dev environment extension file. We pass the build option to tell Docker Compose to build the relative images from their respective Docker files before continuing with the rest of the instructions, which can be a nice little time saver and avoid having to run Docker build. Now, after the command runs, you'll see each container being created in the output that goes to the terminal as it's started, as you can see here in this example. Now, this may take a few minutes based on the speed of your connection, primarily because if you don't have the base images available in the local Docker cache, they'll need to be downloaded first before the instructions can be run on top of those to create the final images. However, after the first time, the process usually happens quite quickly because of that caching. Now, at this point, after everything's built, you'll see I was about to use what would you call a screen pointer, but no one can see my screen pointer. So from the point in the output here where you see attaching to database 1, Nginx 1, PHP 1, under that is the log files for each of the containers. And the reason that I do this or take this approach is as part of the initial testing and debugging process, just to make sure that everything is working as I expect it to, or to be able to see quite quickly if it's not. If something isn't working, then I press Control-C to stop the application, address the issues, and try again. If everything works, then this time, as you can see in this example, I'd pass the D or detach option. When this option's passed, after the container starts, Docker goes into detach mode where the containers run in the background. But as part of that, the logs aren't printed to the terminal. Now, I realize that's kind of a simplistic approach to debugging your setup, but I've found in a lot of instances, it is quite sufficient. I appreciate it's not a deep dive into debugging, but it's a good amount of basics to get you started and help you deal with some issues that you may come across. Now, if you do want to save yourself a bit of time and make things just that bit faster, you can pull the respective base images down locally first into your local Docker cache using Docker pull, as you can see in these examples here. One thing worth noting, and this was some feedback I was given in the previous version of the talk, so I'm not totally sure on it because I haven't had a moment to thoroughly check it, but I believe if you're using Podman or Kubernetes instead of Docker, then you'll have to prefix the image names here. such as Nginx Alpine and so forth, with docker.io as because these images are coming from Docker Hub, they would have that prefix, but the Docker commands added on by default. I just want to put that in there just with a little bit of a marker that I will double check that and make any corrections if need be. Or if someone is ahead of me there, please let me know at the end. Now, at this point, let's assume that our containers are running, there were no errors, or if they were, we got them sorted and our applications are, the containers are up and running. It's still a bit handy though to check that everything's working as expected. So to do this, you can use a combination of Docker Compose PS and Docker Compose logs. We'll start off with Docker Compose PS. This command is analogous to Linux's PS command, which displays process status information. If we run it, as you can see here, I apologize for the slightly small type, but tried to get everything in there that you'd need to see. It'll show a list of the containers in the configuration, including their name, state, and ports. This way, we can quickly see if all of the containers are up and running, or if there's a problem with one or more of them, which is indicated in the status column. If you want to get the status of just one container, then add its name, as you can see here, after the PS command. If you want to look at several, just add their names space separated after the PS command, and it will filter the logs down to just those ones. Now, let's assume that Docker Compose PS showed that the database container had exited, so we want to learn why. To do that, you can view the logs for that container using the Docker Compose logs command, as you can see in this example. Now, by passing the follow option, it'll tail the logs just like when you're using the tail command on Linux or Mac OS. And it'll just keep tailing them for all the activity that's written to them until you press Control-C. If you want to view the logs for all the containers, just don't filter by a container as I have here for the database container. I apologize for my hoarse throat this evening. Now, at this point, the application's running, everything's working. So if we opened up localhost on port 8080 in a browser such as Firefox, then we'd see the application working, as we can see here in this screenshot. So we've now made a deployment locally, but it's still a deployment. So let's have a quick recap of what we've learned and covered. We've created a directory structure to store the Docker files that we need, along with any supporting files. What's more, it's nicely structured around the environments. This way, if you want to add more environments later, you can build on that structure. We created Docker files for each of the 3 services that compose the application, which were later used to create the images which Docker Compose used to launch the containers with. We based each image on an existing base image so that we only had to do as little work as possible, whilst gaining a lot of functionality right out of your proverbial box. We then created a 3-service Docker Compose configuration with a combination of a broad-based Docker Compose file, which was complemented by an environment-specific one. The configuration used the Docker files which we created, one that supported health checks so that we'd know if a service was ready or not, which synced the source files to the running container, yet which let us work locally without having to copy over the files when we change them. We set environment variables, configured the services to auto restart if they crashed, and made the database service available to local database tools. We learned how to start or deploy the application locally using a single command, and we learned how to do some basic status checking and debugging should something go wrong. Now, while there is much more that we could learn, this is already a lot of progress. So with that in hand, let's now move on and see how to build on this foundation by creating the production files and making a production deployment. The first thing that we're going to do is create the production Docker files. Now, I will say, just while we're here, that I had a good discussion with a friend on Slack recently who helped me learn a bit more about using one Docker file, say for a service, rather than multiple ones. As with some other feedback, I just didn't have enough time to kind of get myself up to speed on it and to integrate the changes in time such that I could deliver a smooth talk this evening. So if there are queries as to why I'm using so many, it's just because I guess I haven't gotten to that point yet. But we'll start off as before with the Nginx Dockerfile. The reason for this change is that in production or any other remote environment, images need to be self-contained with all of the source, asset, and configuration files. The work dir instruction sets the working directory for the base path within the image where subsequent instructions operate relative to, if relative paths are used. Next, we add a second copy instruction that copies the contents of the current working directory, all of the application source, configuration, and related files, into the image inside /var/www/html. Then, using Alpine's package manager, it installs the required binaries that the image will need, then runs npm install to install the front-end dependencies. Now, if you saw me tweeting, I think about half an hour, around about 6:30 or maybe 6:15, I had almost gotten a multi-stage build approach here. Almost gotten that working such that I could use a Node.js image first, so that I didn't have to actually add these, install Node.js and npm here. But it wasn't quite ready in time, but I will have that in the updated slides. Anyway, with everything in place, it finishes up by running npx and Tailwind CSS to build the application style sheet from the base configuration, instead of generating a sizable development version. If you're not familiar with npx or Tailwind CSS, that's absolutely fine. The reason that I mention them is that the generated style sheet, because of this approach, will only contain the required CSS properties, and after it's built, be minified. This way, the file in production will be as small as possible and be generated only when required. That way, it doesn't have to be stored under version control or looked after by us. Next, let's look at the changes to the production PHP Dockerfile, or the differences, I should say. Now, it's kind of long, but I've split them up over a few slides so that they're just that much more readable. Starting off with the from instruction. Now, note at the end of the line that it adds the string as composer to the end of the instruction. This enables multi-stage builds. Now, quoting the official documentation, with multi-stage builds, you use multiple from statements in a given Docker file. Each from instruction can use a different base image, and each of them begins a new stage of the build, hence the name. Because of this, you can selectively copy artifacts from one stage to another, leaving behind anything that you don't want or need in the final image. Now, while they can add some complexity to the build process, I feel, and experiences backing me up so far, that when done well, multi-stage builds can both simplify the process of building an image and reduce the final image's size, often significantly. Now, the reason that I've added as composer to the end of the first instruction is because I only want to build composer in the first stage and then pass it on or be able to retrieve it in the next stage where it's going to be used, and leave all the dependencies and so forth behind. So given that, it runs It uses two run instructions to install the required packages that Composer will need and generates the Composer binary. For complete transparency, I have lifted these instructions in the second run instruction from the official PHP Composer image. They're not mine. I just want to be honest about that. Next comes a second from instruction. So this would be lower down that same Docker file. It uses the same base image as before, but note that it's named dependencies. This is because it will use Composer to install the PHP dependencies which the application relies on. As it's the last stage in the build, I didn't have to name it, but I thought it would be a good thing to do for sakes of consistency. To simplify the rest of the instructions, the work dir instruction is used. After that, to copy instructions are called to copy the application source file into the image and to copy the Composer binary from /user/bin in the Composer stage, because we've added on the option from and then set the name of the stage to copy from, to /user/bin in this, the final stage of the image. Just to reiterate, nothing else from the first or Composer stage will remain at this point from that first stage. Then Composer install is run to install PHP's dependent libraries and packages, and the MySQL PDO extension is installed. Now, the database image is no different than before, so I'm not going to rehash that again. Right, now that the Docker files have been created for the production environment, it's time to build the images from them. To do that, you use the docker build command, as you can see here in these three examples. Now note the options supplied to the command. We use the file, or we could also use the shorter F option to provide the name and path of the Docker file containing the build instructions for this image. We're doing this as the Docker file is not located in the directory where the docker build command is run from. We also supply the path to the image's context, which is the dot at the end of the last line of each of the commands, and all commands will run relative to that directory. And thirdly, we pass the tag, or we could also use the shorter T option to tag the image. Now, there are a couple of things to note with the tag option, which is why I've used it. Note that the tag or the tag label starts with, as I've highlighted here, web dev with Matt, which is my Docker Hub username. By doing this, when the images are pushed to whichever container registry you push them to, the information doesn't then need to be supplied, as it will automatically be retrieved from the image. We could also supply a Docker registry URL if we were using a service other than Docker Hub, such as DigitalOcean's container registry. We've also given the image a name, which is the string before the colon, and a tag, which is the text after the colon. We can call these what we want, so long as they're unique to our account, and ideally they make sense and they're helpful for us and for everybody else who's using them. Once the images have been built, we can confirm that the images are ready, because it's always good to double check your work. And we do that. I'm hoping you're seeing a pattern to what I'm doing here with what I want to do and the command I'll use by using the docker images command. And what this does is give you a listing of all the images in your local Docker cache. Here we see the repository and tag names, and that they were created just a little while ago. Now, if you have a long list of images because maybe you're working on a number of projects, maybe you're creating images just to test out concepts and ideas, then it's more than likely, especially the longer you do it for, if you don't regularly prune and clean, you'll have a long list of images in your local Docker cache. So it's going to get a bit hard, and I didn't do a massive dump just for sakes of tidiness. It's going to get hard to sort of see if the image or images that you want are actually there and when they were last updated or created and so forth. So one way to simplify the output is to use the filter option, as I've done in this example here, so that it will filter out any image that doesn't meet your criteria. Now, in this example, the available images are filtered based on a combination of the repository and tag columns joined by colon. Now, I appreciate if this is your first time seeing it, that probably doesn't mean all that much. The reason I'm kind of saying this is that whilst the filter option is really powerful, once you get into it, I don't find that the documentation really does much justice to the power that it gives. I think they've been quite light on with documenting it properly. So you can, or at least I did, I spent actually a good chunk of time after reading the official doc actually Googling around and being on Stack Overflow to find out how to actually use it. But by that's just a bit of too much honesty there. Anyway, with the images now built and tagged, we now have to store them in a Docker registry so that they're accessible no matter where the deployment is run from. So for the purposes of this talk, I'm using Docker Hub, or you can assume I am. If you prefer, you can set up a local Docker image registry using Docker Registry, or use a different service such as DigitalOcean's container registry. For what it's worth, I'm not plugging DigitalOcean. I'm not paid to plug them. It's just they're the service that I use most, so I'm most familiar with them. So I kind of integrated that into my talk a bit. As you might expect, by this point, we'll use the docker push command to push the images to the remote registry. Before we can do that, though, we have to call docker login first so that we authenticate against that repository. But after that, we can push the images using docker push, as you can see in these commands. Just to reiterate, we don't have to pass the registry URL or the account name to docker push, as that information is retrieved from the image which we added when we ran docker build. Now, at this point, we need to update the production Docker Compose configuration for a production deployment, and we are almost, is it a universal English phrase? We're almost home and hosed. So, and this would be docker-compose.prod.yml. You can see, similar to our local development configuration, it'll have the same services with largely the same configuration for each one. However, there are a few key differences to pay attention to. The Nginx service now uses the Nginx image that we just built and pushed to the repository. Instead of mapping port 80 in the Nginx image to port 8080 in the host, it's mapped to port 80 instead, which is what you'd expect for a production deployment. Depending on your security settings, you'll have to make sure that you add your existing user to the relevant group, such as Docker, staff, ADM, or admin, so that it has sufficient permissions to bind on port 80, or use sudo to obtain sufficient privileges. Similar to Nginx, the PHP service uses the image that we created earlier and the composer dependency shared volume, which we set up before. And the aim of that was to put everything in a shared volume for that image, but I believe I actually don't use that anymore, so that's a little bit of a legacy. I apologize. Similar to the other two services, now we're on the database service. The database service uses the database image, again, which we created earlier. And secondly, it also sets environment variables, the same 3, but this time, and you'll note that the example is different to before, we're not actually setting the value explicitly here. We're not explicitly setting the environment variables for the database image. Instead, because of this approach, they'll be retrieved from the environment where Docker Compose is run from. Given that, we have to set them in our environment before we can run Docker Compose up. Now, as I'm sure you're all aware, there are any number of ways to set environment variables, but for sakes of simplicity, we're going to use the export command. And as this is a test application, I think it's fair to say that there are no stringent requirements to set strong passwords and related credentials. So please don't burn me for setting password to password. Before we deploy the application to production, as before, let's test that it works, but locally. We can do this by using Docker Compose up, as we did with the development version, but this time using the default Docker Compose file and the production Docker Compose file instead of the development version. Everything else remains the same. When the terminal's output stops scrolling, we'll check that it's working by running Docker Compose ps again, using the production configuration file. If all of the container states are listed as up, we can be pretty sure that the deployment will work. If one of the container's status columns is listed as starting, give it about 15 seconds, maybe less, and check again just to allow for the health check to run. And if one or more of the containers isn't working, then check the logs to see what's wrong. But let's just assume that the deployment was a success. We'd now run Docker Compose down to stop the application, as we don't want to run it locally anymore. So after all of that, and we are very close to the end, it is finally time to deploy to production. However, there's always a little caveat. Before we can do that, there is one more thing we need to do. And that is, we have to tell the local Docker client to use the Docker Daemon running in the remote host, not the local host, which by default runs through a non-networked Unix Linux socket. Now, to connect to it, we can do one of three things. We can set Docker_host environment variable before running any of the Docker commands. We can use the capital H or host options when running the Docker commands. Or thirdly, and I believe this is the preferred official Docker approach, we can create and use a Docker context and then run the commands as normal. Now, each of the examples here specify the Docker Daemon socket to connect to before running a Docker command. So on the first line, you can see that I've combined setting of the Docker_host environment variable with the command. In the second one, I've exported it and then run the command. And then in the final two, I'm passing the capital H and host options when running the command. While I've found this helpful, taking this approach here, or any one of these, helpful in building a GitHub action-based workflow for running commands locally, I did find it frustrating. Try that again. I just muddled myself. I found this approach helpful when using GitHub actions, or the GitHub actions to deploy the application. When I was running it locally, however, I did find it a little bit frustrating to take this approach because maybe it's I'm mid-40s, dad with 2 kids, and I don't get that much sleep. I would periodically forget to set one of the options, or I'd set it one time and then I'd do a subsequent command and forget it, or set it incorrectly. And so I'd get sort of mixed results, which would lead to quite some frustration. So from speaking personally, when running locally, I would generally recommend and do use a Docker context. Now, I've been saying Docker context quite a lot in the last couple of slides. To quote the docs, a single Docker CLI can have multiple contexts. Each context contains all of the endpoint and security information required to manage a different cluster or node. The Docker context command, as we'll see, makes it easy or simplifies the process of configuring these contexts, and I guess in short, letting you tell your Docker client which host to connect to without you having to specify that information explicitly each time. So to boil that down, by default, there's a Docker context named default, which is kind of handy, that references the Docker daemon on your local machine. So if you don't use Docker_host, the capital H or host options, then you're making use of that default context. However, by using the Docker context set of commands, which we'll see in a sec, you can add any number of additional ones, or basically make it easy for yourself to refer to any number of remote Docker daemons, which is handy when you're deploying to multiple environments. So when working with contexts, you only have to do two things. 1, create a context. 2, set your new context as the default one to use. After that, you just run your Docker commands as you normally would. One less thing to have to think about. To create a Docker context to any given remote host, you first run the Docker context create command, and then the first option after that is the name of that context. In this case, because there's only one, I called it remote. And then you use the Docker option to specify the details of connecting to that remote host. So in this case, I'm connecting over SSH. My user is named deploy, and we could put any, well, in this case, DigitalOcean or whatever remote host you're connecting to, whether the user host name or IP address. And then to set that one as the default one to use, you run Docker context use and pass the name of that new context. Then, if you just want to be totally sure that you are using it, or if later you want to check which one you are using, you then use the Docker context ls command. And what that will do is dump out or list all of the contexts by name, along with the endpoint they connect to and some other details. And the default one, or the active one that you're using, is the one with the asterisk after it in the name column. I have dropped some columns from the output just to make the output easier to read, and so that you don't have to squint because the text would be so tiny. Right. We're now ready to deploy the application. So to do that, we first, because I'm going back to my Docker host preference, the Docker_host environment variable, and then run Docker compose up with the D option. So it'll go into detach mode, and the file option passing to it the base Docker compose file and the production Docker compose file. As with every other time, you should see the containers starting up, but this time it'll all be happening on your remote Docker daemon. So keep in mind that it may take a bit of time for the remote host to download the images for that first time and cache them locally. However, as always, after that, it should happen quite quickly because it'll have everything cached. So did it work? Well, as with every other time, good to check. But this time, because we exported the Docker_host environment variable previously, we can just run our standard Docker commands, which we covered, including Docker compose ps to check the status of the containers on the remote server, and Docker compose logs to check their error messages, or just their logs in general for error messages. If everything's working, then if you load the application in your browser using the remote host's IP address or domain name, then you should see it render beautifully as it did previously. So that's us. That's a deployment to production. So let's have a quick recap before we just finish up. Hopefully, fingers crossed, as they do here in Germany, thumbs as well. Hopefully I have imparted several things, those being how to build the application images, how to store the images in an accessible registry, how to tell the Docker client, no matter where it may be, which Docker daemon to connect to, no matter where it is, how to build a deployment configuration, and how to deploy the application to a remote host of your choosing. While there were many new things to learn about, and I apologize that there were just, I guess, so many things going on, at this point, you're now ready to deploy your application to any remote environment of your choosing while staying within a rather simple Docker-based ecosystem, or rather simple set of Docker commands. And at this point, you've just completed the first successful deployment. While it works, and I don't want to detract from that success, using this specific approach requires deployments to be performed manually. A better way would be to integrate this approach into a CI tool such as GitHub Actions, Circle CI, or TeamCity. I haven't included a setup for any one of those in the talk because I just wanted to focus on the essentials of what we need to do. But if you'd like, I'm happy to share one that I do have. So, thank you very, 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 very much for listening to the talk. If you would like to delve deeper into what I've covered this evening, then I have written a book called Docker Essentials, which you can find at dockeressentials.com. Why the book and not just the talk? Well, it covers the topic in a lot more detail than I've been able to deliver in the 1 hour and almost 9 minutes tonight without going overboard. It's packed with a lot of tips, tricks, and pointers that I've learned along the way. It will soon have all the feedback that I wasn't able to include in the talk as well. If you're interested, you can download it for free from dockeressentials.com. Thank you very much. And at this point, if there are any questions, if everybody's still awake, please feel free to ask away. I hope someone's still awake. Right. Now I see where I'm going.
Yeah. Can everyone hear me? Okay. Well, that was a wonderful presentation. I mean, even though there is some echo here on my account. Let me see. Okay. So there was a problem with your slides appearing. It was a little bit garbled, but someone shared your presentation link, so everyone was following along your presentation. So in a sense, it worked pretty well. It's good to have the voice with the slides. That's why you give the presentation. Unfortunately, it was a little bit garbled in the output, but I think we all managed. I saw, at least I had a question, so I know that I had one. Where is my question? Mark has a question. So, do you version your images between updates when you deploy to production? And I'm referring to the book Continuous Delivery of Jess Humble and Dave Farley, where they say you need to have created artifacts that you can deploy and replace if needed.
Yeah, hang on. I haven't muted myself. Good. I do. In the GitHub Actions workflow, I did because. And can I get the link to that book, by the way? Just at some stage. Yeah. How I did it was I kind of riffed off what I've seen on Docker Hub and other places where there'll always be a latest. So if you don't provide anything, it will just link you to that one so you can get the latest and the greatest. But otherwise, I just have been basing it on like my a tag in my application, so that it kind of has nice parity with like version 1.1 point whatever. I'll have an image that sort of, or the images for each of the containers will have that same number as well. So you could roll back to a particular point in time. Not that I've done it yet, but that was my idea, at least, that if I had to roll back for some reason because something went wrong, you can, instead of use latest, you can just pick a particular tag or release number. So yes. And I noticed a lot seem to do it, but my approach so far hasn't been too sophisticated. It's just using the tag, which I think most CI tools will just give you or make available as an environment variable. Is that cool? Or
I think, yeah. The sound is a little bit on delay. I think the answer is awesome. Next question: how do you store persistent storage across multiple containers? I think that's a good one.
Okay. I started to talk about it, but what I had in the previous version of the talk was I had in one of the slides, there was a composer underscore dependencies shared volume. And what I was doing was making all of the source files, putting all of the source files into that, and then sharing that across each of the images. And so in so doing, you're not duplicating the files, but you're sharing them across any number of images that you want. I think I covered it in more detail previously, but as an admission of kind of embarrassment, perhaps, I kind of forgot why I put it there. So I started to take it out, but I didn't fully take it out. But that's what I was doing, because I think I had the need to, I thought I did, to share the source files around, but I didn't want to, I wanted to set them up once and then just share that and not duplicate them across images and have these large or bloated image sizes. I'll double check those slides and get that back in there.
Okay. The last question, I think, is there's more. Could you use this for demo applications of open source projects? Would you then look at spinning up a separate instance per demo or build in a reset every X hours? By Jelma.
Well, yeah, you could. Yeah, you could do it for an open source app. I'm not sure about the second part of the second question, but is the question meaning like you would deploy like a demo instance of your open source project? I'm just a little lost on the second question. Sorry.
Yeah. So he answers yes. So. Oh. Well, if you're talking about demo applications, if you want users to run a demo of your open source or proprietary software, what you can do is have like a pool of images, up and running, the same way that you would spin up a worker for your CI/CD, and if no one is interacting with it, you let it shut down again. But it all depends on how big a pool you want to provide to your customers. or to your users.
Cool.
There's more. Was wondering, is SQL files in PDO and migration times. Is this about the time it takes if you have a dump from a database and you want to run it inside the container as you build the MySQL database container? Is this what you mean? Or is it when you have the migrations in your PHP application and you want to execute those inside the container before it actually executes? Because I think the latter is going to be a little bit tricky if you have the separation between your database containers and your application containers. So your database containers need to be up and running. Am I correct, Matthew?
I guess to hang on. The reason I picked that approach I did in the example was it was partly to just sort of take advantage of the functionality that that base image provides. It wasn't, I guess, as I tried to mention it, it wouldn't necessarily be the approach that you take like in a for your real world app, but more just an example. And I guess why I was sort of stressing that you'd probably use any number of other different tools like DB migrations, an external service. So you don't need to kind of take this one as a what would you say, a best practice or a good example. It was just for sakes of this example app to.
Well, consider just that in a testing phase where you want to test against a particular version of an application, you have your data structures in place where you will have some testing data inside the dump, so to speak, and that SQL file will be used every single time that you execute your tests against that particular version of the application. So in that sense, it makes sense.
Yeah, like
that's how I use the functionality. Okay. Next question. Oh, are you eager to participate in vidcasts where we can talk more serious questions?
My brother tells me I have a face for radio, so absolutely.
All right. Well, Alex, we have a open discussion later on. You can exchange some information with Matthew if Matthew is eager to participate.
Yeah.
And you can take it from there.
I'm absolutely there.
Dumps are useless. You need front-back migrations in parallel during deployment of different versions. Is this a question? I think it's more like a statement.
I think so.
Yeah. Next one. Problem with containerized apps is cost for me if I want to run it publicly, that is. That's why I often fall back to VPS, which is
yeah.
And that's also a statement. Okay. I think that we're through the questions, because now everything is published as text in the question mode. Well, Matthew, first of all, during your session, I felt a little bit sorry for your throat there. I hope you have close by, so you can make sure it's nice and wet. And second of all, thank you very much for this presentation. I really enjoyed it.
That's all right. Thanks for having me. I'm sorry, I guess, for my own part about the audio video delays.
You were awesome. It was up.
Thanks, man. I hope
You,
that I delivered me and it was interesting and fun to listen to.
yes, absolutely. Especially with that, um, you were having these moments of Australian slang, and then you started to sound more like a European speaking English.
Did I? Oh, really?
Yeah, yeah. You should re-listen to the YouTube recording.
Yeah,
But
absolutely.
it was awesome. It was awesome,
Thank you.
and also yeah. Um, the way that you articulate the elements on your slides, it's perfect. Yeah. Um, I think we want to have you again on this meetup, if
Thank you very
possible.
much.
Hopefully in person, so you can be
Yeah.
on stage.
I haven't been to Belgium yet, so and I'm there.
All
If I
right,
can
all right.
if I can get a flight there and all the rest of it and my 20 COVID passes and
Where are you in Germany?
oh, I'm just outside of Nuremberg, down in the south.
Uh,
Um, uh,
Everything is like a 4 drive.
oh yeah, that's right. It's not Australia. That's yeah, good point. Sorry,
Yeah,
I keep forgetting after all these years that the distances are so much closer here.
yeah, and we have public transportation called trains. They are very fast.
Right.
So,
Yes. Very
so
true. I'm there.
anyway,
Anytime. Yeah.
do you have something to say for the this new year to our audiences?
Um, I didn't have anything in mind. Am I meant to have something at this point that I've
No, no, but
other than I don't know. I hope everybody's healthy. I hope everybody's not, putting up with too many different rules and regulations and stuff with COVID. But no, nothing much. I just hope that this helps. Maybe if people were thinking about using Docker, although I will slightly say, not necessarily Docker, but the containers
mhm.
overall, that hopefully this maybe gives some motivation to have another look if they haven't tried it yet. I hope that this talk maybe makes sense of a bit of the Docker marketing of. I was talking to someone. I'll keep this short. I was talking to someone I think just a day or so ago that it was Cal Evans actually on the Voices of the Elephant because he said, "Why did you create the talk?" I said, "Because when I created it, the Docker marketing was kind of like that Java, write once, run anywhere, but you write it and then you go, how do I run it somewhere else?" Docker kind of seemed to be the same thing. So I thought I had all these problems. I just wanted to simplify what are the absolute basics to get me from development to production. So I hope if someone
Yeah,
else has had the same troubles that this gives them a clear path. But otherwise, I hope you're having a good year and things are going good.
yeah, yeah, yeah. It's a new year, new opportunities. There's a lot of PHP goodness out there, and yeah, I'm very excited to see what the world is creating with all the tools. So. Anyway, Matthew, thank you very much for being here. I really enjoyed your presence, and the session was awesome. I even took, well, a lot of notes. So,
Cool.
so
Thank you
yeah,
for having me.
I learned a bit. Um, but I think that most of the people now in the audience are very eager to win one of the elephants. So I think it's raffle time. What do you think?
Yes,
All
absolutely.
right. All right. If you want, you can stick around. We're going to have like a nice chat session afterwards. So
Mhm.
feel free to join.
Yep.
Okay. I'm going to make you guest again. So
Sweet.
thank you and see you in a bit. Okay. Well, it's raffle time. Let me just get this piece of software here. Um, okay. Where's my deck here? And let's do HP. Here we go. For some reason, my microphone is in double tap. Let me see if I can adjust this. It should be better now. Okay. Let's just get started with this. I have all the attendees listed here. The only one I forgot was Matthew. It's himself. So everything is shuffled, and let's give it a spin. Rick Lambrechts. Yay! Maybe I should mention it. Rick, you just won an elephant, and the color is blue. Now we go for the pink elephant. Matthew, congratulations. Well, unfortunately, we don't have any other elephants to give away, but that doesn't mean that next month we can raffle another pair of elephants, or if we find a sponsor that could deliver us more elephants. So thank you very much for being here. Let me go back to the screen. There you go. I'm going to make sure that the people are going to be set in the breakout rooms, and I will see you there. So if I don't see you, thank you very much for attending, and I hope to see you all next month. So don't forget, it's the second Thursday of the month. So we'll see you there. All right. Bye-bye.